So since you understand this now, congrats. Remember, whenever you want to find the direction of the vector, it's always this formula you're going to use, right? Tan theta is equal to your y on your x. Okay. And for if you plan on doing physics, like you see physics for CSEC, physics for K, it's the same thing, right? Just don't forget it. Okay, let's practice this now. Can you find the magnitude and the direction for the first one? And let me know when you finish. So you find the magnitude, which is what we did before. So it's the square root of x squared plus y squared, and then the direction, yeah, for both of them. Then direction, tan theta, y on x. Do the first one though. When you finish with the first one, then let me know. We'll go through that one, then we'll do the second one. Let me go through this question first, and then Jules, you tell me exactly what you don't understand. Number one, we want you to find the magnitude and the direction of this vector v. And they said the column vector v, is 3, 4. We said to find the magnitude of any vector is the square root of the x value squared plus the y value squared. Remember, the column vector is always in the form x, y. So what does that mean? My top number is always x, my bottom number is always y. So looking at the vector that they gave me, x would be 3 and y would be 4. And therefore, the magnitude of this vector v would be the square root of 3 squared plus 4 squared, which is going to give me the square root of 9 plus 16, which is equal to 9 plus 16 would give me 25. So the square root of 25 is going to be 5 units. Just a little note. In previous topics, I told you, whenever finding the square root is always plus or minus, right? Unless stated otherwise. In this case, this is one of those times where you don't consider plus and minus, right? Why? Because magnitude and direction, they're completely different. Actually, no, let me not say it like that. I said that another name for the magnitude is the length, the size, or modulus. Yes, I did modulus with you time. The trig. When we were finding the acute angle alpha, I told you, you always have to find the modulus of the value. Modulus meaning the positive value. So let's say I had -4. If I tell you to use the modulus of -4, which is represented like this, it's 4, right? So the modulus just means the positive value. So the modulus of -4 is 4. Because magnitude is also known as modulus, modulus means always use the positive number, then I cannot consider -5 because -5 is not a positive number. Modulus is always positive. Modulus is the same as magnitude. And since modulus is always positive, the magnitude must also be positive. So I don't consider the plus or minus square root of 25. I'm just dealing with the positive value, which would give me 5 units. Positive 5 units. Just to clear that up, right? Is everybody good with this?
Yes, I understand.
Yes, miss.
All right.
I get all I understand the magnitude. What about the direction?
Yes, just do you understand how I got this formula in the first place?
No.
No. Okay. Do you understand what I did here with this full triangle?
No.
No. See, this is why I ask questions, you know. That's why I ask if people understand what I'm going through, so I don't leave you behind. And this is an example, you know. A, B. So like I said, we just sticking with this AB vector. Why? Because, I mean, why not? So it's AB, the vector AB. We said we're going from A to B. And when we were practicing actually drawing this vector, we use our column vector that they gave us. And then from my starting point, I counted how many of the spaces they write and then how many of the spaces up, right? Because that's the column vector they gave me. It was two positive numbers. So I counted how many of the spaces going to the right and then how many spaces going up. So this was my X. So whatever value was on top, this is what I counted. So hey, positive 2. If I was using this column vector, it would be 2 units to the right. So this horizontal line here, this horizontal displacement is my X. The Y, let's say it was a positive 3, then I'll move 3 spaces up. And that would represent my displacement along the Y-axis. So that's why I labeled this X, displacement along the X, and then this Y, because it's displacement along the Y-axis. And I said, if you want to find the direction of a vector, so for math, add math, or if you're doing physics, you did this too. If you want to find the direction of a vector, you always consider the angle that it makes with the x-axis. So you see the angle this vector here makes, so this arrow with the x-axis, which is this horizontal line. So what do I mean by the angle it makes with the x-axis? The angle between the vector, so the arrow, the angle between the vector and the x-axis, which would be this angle right here. The angle between the vector and the x-axis. X, vector, angle between, theta. This creates a right angle triangle. And we know whenever we deal with right angle triangles and trying to find the angle, you use your trig ratios, SOHCAHTOA. You have the opposite side, you have the adjacent side. Opposite on adjacent, that's the tan function. So tan theta, tan of my angle theta would be opposite on adjacent, opposite would be y, adjacent is x. And that's why I have, whenever you're finding the angle between the vector and the x-axis, it's always tan theta is equal to y on x, because y is the adjacent side, x is the opposite side, and that's the tan function. You understand that? 2. Do you understand? There you go.
I had a little bit of noise, but yeah, I think I'll just review it again and try, but I don't understand. I'll try. You would have done that in physics too, when you're doing resolving vectors. That's one of the things you're required to know when finding the direction of a vector. So if I wanted to find the angle theta, so it would be tan, what am I saying, tan theta, let's just pretend that's a theta sign, is equal to y and x. Y is 4, x is 3. So that's 4 on 3. So if I wanted to find the value of theta, then I would find theta is equal to tan inverse, tan inverse
would in fact give me 53.1. Remember, we're doing degrees. Degrees. So that's my answer there. So if my vector looks like this, so this is my vector v. If that's what my vector look like, let's say I went this way. So I have two positive numbers, right? So that means I went to the right and I went up. From my starting point, I moved 3 spaces to the right and 4 spaces up. This right here would be that angle. This would be that angle. The angle that I'm referring to, this 53.1, that's this angle right here. The angle from my y. So let me y now, x. X is 3, y is 4. And this angle right here, so let me just name it theta. Let me just leave it like that because this is giving me trouble. This angle right here between the green arrow, which is my vector, and this and the x-axis right here, so this horizontal line, the angle between them, that would be my 53.1 degrees. Everybody good with that? Well, 2.
Yes, Miss, I understand.
I understand.
So I won't do the, I won't actually write the second one because I'm already over the time. C, the vector C, if I'm trying to find the modulus of that, x is 3, y is minus 4. So it would be 3 squared plus minus 4 squared will also give me the 5 units, right? Because 3 squared is 9, and then minus 4 squared is positive 16. So 16 plus 9 is 25, and then the square root of 25 is 5. What if I want to find the angle though? So notice the relationship between this one and this one. This just has a negative number, right? So I hope you notice that. So if I wanted to find the direction here, I use tan theta is equal to my y and my x. In this case, y is not positive 4, it's negative 4. When you found the value of theta, so you said tan inverse of negative 4 and 3, you got a negative value, minus 53.1. But what does that mean? I can't have a negative value. What nonsense is that? From trigs, when we are doing trigs, I told you positive angles are measured counterclockwise or anti-clockwise. Negative angles are measured clockwise. So instead of my angle looking like this, so remember from trigs as well, we always measure angles from the x-axis, right? So going from the x-axis, it would be in this direction, right? So I'm measuring my angle in this direction for this one. That's counterclockwise, and that's why the angle was positive. But if I drew this one, right? If I drew that diagram, whatever that vector diagram looked like. Let's say this was my starting point. Actually, this was my, so I want to draw this vector, right? So I drew my Cartesian plane or whatever. You don't really have to draw a Cartesian plane. But anyways, I just want to do a quick sketch of that. So this is my starting point, 3, positive 3. So that means I'm going 3 spaces to the right, 1, 2, 3. But then this number, that's a negative value, negative 4. So what does that mean? Instead of going 4 spaces up, I need to go 4 spaces down. So from this point, I go 1, 2, 3, 4 spaces down. And this right here would be my next point. So this arrow going down like that Oh my. Let's just pretend that's a straight line. Down like that. This is actually what vector C would look like. Vector C. So unlike my other examples where the arrow was pointing in a positive direction, so let me not say a positive direction, but it was up. Let's just say it was pointing up. This one is pointing down. So if I wanted to find the angle that it makes with the x-axis, aka the direction of the vector, that would be this angle right here. The angle between the vector and the x-axis would be this angle right here. And remember, from trig, we said we always measure angles from the x-axis. So going from the x-axis to this vector would be going in that direction, which is a clockwise direction. Whenever you measure an angle in a clockwise direction, it is always negative. Negative angles are measured in a clockwise direction. And because I am going in a clockwise direction here, from my x-axis to this vector, sorry, from my x-axis to this vector, it's a clockwise direction, and therefore my angle is negative. And that is why you got negative 53.1. That negative sign just tells me, oh my gosh, I am so sorry. Right. This negative sign just tells me that the angle is measured below the x-axis or in a clockwise direction. Do you understand that? So the negative sign doesn't really mean anything, but that the angle is measured in a clockwise direction and it's below the x-axis. That's all it means. Do you understand that? All right, that's fine. Do you understand why? Do you understand this? The whole negative side thing? Okay, I have one person answering me, so I'm gonna assume everybody else is fine. Okay.
Miss, there's no need to assume when Kevon Morgan is here.
All right.